on the video lecture. So you have gone through on Sunday, right? Part 3, Part 1, Part 2 you have gone through before the Raya. Part 3A and B you have gone through last Sunday. So basically, these 3 parts are some very fundamental theory regarding heat exchanger. So in part 1, part 2, you were given introduction regarding different types of heat exchanger, right? How does it look like? Some of you, this is not something new to you because during your first semester in engineering drawing, actually you were given a project. You were asked to construct 3D model of a chemical plant, right? So some of you were assigned to construct a 3D model for heat exchanger, right? So heat exchanger should not be something very new to you. Okay, so so in part 3, in the video lecture, so you were introduced to overall heat transfer coefficient for a heat exchanger. The symbol is U. So you have 2 types, right? UI and UO, because U depends on surface area. So if you still remember, the professor mentioned U is meaningless without defining what is the area you refer to. It's either AO or AI, right? If the U is defined according to AI, then the U is called UI. If the U is defined according to the outer surface, okay, or AO, then the U is called UO. So remember, U is meaningless. Is meaningless without first defining the A. Okay, without first defining the A, the type of surface area you refer to. Okay, then after that in part 3B, the professor demonstrated how to use this U, okay, how to determine U, right? 2 examples were given. So this is what you have gone through. Then over this weekend, we want you to go through another 3 video lectures. Okay, this part is very important because in your test, not in the test, in the final exam, okay, for your information, in the final exam, there will be one question. There will be one question, so which contribute to about 25% of 100% in the final exam. One question will be on heat exchanger, right? So, and very big portion of it is about analysis of heat exchanger. Okay, what does it mean by analysis of heat exchanger? Simply means this. Let me show you. Okay, we know that for heat exchanger, heat transfer, Q, okay, right, amount of heat transferred, right, in the heat exchanger, because we know heat exchanger is basically record. Okay, anyway, I'll record because this is just an overview. Okay, so heat exchanger basically involve exchange of heat between 2 fluids, right? One hot fluid and one cold fluid. Got heat exchanger involve exchange of heat or thermal energy between two fluids, right? One is cold fluid, one is hot fluid, right? Cold fluid is the fluid with lower temperature, lower inlet temperature. Then hot fluid is the fluid with higher inlet temperature, right? So when the two fluid get in touch with one another through the surface, then exchange of heat occurs. So what we want is we want to use heat exchanger to heat up and to cool down the fluid, right? So we know the basic formula involved. Q is mCp delta T, right? This is what you have learned in the high school. And this is the general formula for heat transfer in a heat exchanger, right? So UA delta T, right? So for your information, delta TM, there are two types. Okay, basically, it depends on types of heat exchanger, right? As you can see here, types of heat exchanger affect the delta TM. M here means mean. Okay, mean. So mean temperature difference depends on types of heat exchanger. So if it is 1-1 type heat exchanger or double pipe heat exchanger, 1-1 it means it's a one shell pass and one tube pass heat exchanger. Right? Double pipe, you know lah, huh? So if it is a 1-1 type or double pipe heat exchanger, then delta Tm equals to delta T log mean. What is delta T log mean? Delta T log mean equals to what? The delta T inlet minus delta T, I can't remember the formula. It's a difference between the and ln, right? Delta T inlet, delta T outlet. Okay, so actually you have learned this, right, in convection. Okay, so you need to use delta T log mean. For heat exchanger, you must use delta T log mean. Okay, just that for 1-1 type and double pipe heat exchanger, you don't need to do any correction. So you can use delta T log mean directly. But for multiple passes heat exchanger, okay, it means non-1-1 and double pipe heat exchanger, like for example 1-2, 1-4, 2-4, 2-8, 2-12, right? Now multiple passes heat exchanger, then you need to do correction. You need to add a correction factor inside when you determine delta T mean, right? So it means basically is something like this: is UA delta T log mean then times FT, right? For the case of 1-1 heat exchanger and double pipe heat exchanger, FT equals to 1. This is for 1-1 type and double pipe heat exchanger. FT equals to 1. Okay, for multiple pass, FT, you need to determine using graph. Okay, all this will be explained in the video lecture. So I want you to go through the video lecture. Now I'm giving an overview. Okay, so the professor teach you how to do correction, how to get the correction factor using the graph. Okay, for non-1-1 type and non-double pipe type heat exchanger, you must do correction. Okay, so delta T log mean needs to be corrected by multiplying the delta T log mean with FT, correction factor. Okay, so this is what you will go through in the 3 video lectures after this. Okay, so yeah, by using this formula, actually we can determine how much heat can be transferred using the heat exchanger, right? We can also, let's say, if it depends on what kind of information you were given, right? So as mentioned, so there are 2 types. You see, there are two methods for analysis of heat exchanger. One is called LMTD method. Another type is called NTU method. LMTD is log mean temperature difference method, right? NTU is number of transfer unit method. There are two methods you must learn. Okay, you must master these 2 methods of analysis of heat exchanger. Okay, because you were given different information, right? Depending on types of information provided, then you need to use different method. Okay, so I give you some more information, right? LMTD method can be used when inlet and outlet temperatures are given, right? For example, you were given, right, heat exchanger. Okay, I don't know how to draw, sorry. Okay, so this is shell, right? Shell. This is tube. Let's say this is one type, right? So one pass by the shell one type at one time. The tube also one time. So here you also have. So this is let's say this is a higher temperature. So this TH in, then this TH out. TH mean hotter stream, right? Hotter stream enters the heat exchanger with TH1, then exit the heat exchanger with THO, right? Then here T cold, yes, let's say, okay, cold stream enter the heat exchanger with TC1, exit the heat exchanger with TCO, okay, T cold out, right? So let's say all this temperature, TH1, THI, THO, TCI, TCO are all available. Inlet, outlet temperature are all available. Then, and you are given U, okay, overall heat transfer coefficient of the heat exchanger is given. Okay, if it is not given, then you need to use the information given like last time, right? Explained by the professor how to determine U. You need to use the formula. This is the formula, right? To determine the U. Okay, sometimes in the exam, U will be given to you directly to save your time. But let's say if U is not given, but you are given the K value of the tube, you are given the H inside, H outside, then you know how to determine U, right? If you pay attention, if you have gone through the previous lecture, then you know how to determine U. Okay, sometimes U will be given to you, sometimes not given to you, but instead you'll be given HI, HO, you'll be given K value of the tube material, let's say copper, K equals to, let's say, 250, right? Then using this information, you can determine U, right? Okay, so with all this information, normally this kind of scenario, you are asked to determine what is the size of the heat exchanger. Okay, in this case, you need to use LMTD method. Okay, because all this information are available. Okay, LMTD method is kind of easier. Okay, but in another scenario, let's say you only know inlet temperature, you don't know outlet temperature, right? Let's say you see outlet temperature are not given. You need to determine. Okay, TC out, TH out are not given. Okay, you only know TH in, TC in. You don't know TC out, TH out, then you will be in trouble. Okay, because you cannot determine Q. You don't know the Q because both outlet temperature are unknown. Okay, then in such a case, you have no choice. You cannot use LMTD method anymore. You have to use NTU method. Then the professor explained the basic principle, the theory behind NTU method, okay, and how to determine TC out and TH out. Then after that, you can determine the Q. Okay, so this is why these two methods are important. In order to solve problems, to determine the size of heat exchanger, to determine the outlet temperature, right, to determine the Q, you need to use one of the method. Depends on the information given to you. Okay, so I want you to go through the lectures and learn how to use LMTD method, okay, how to use NTU method to solve the problem. Okay, so yep. So after going through all this lecture, we can say this topic is done already. Okay, then you have more information. You have more knowledge, which enable you to complete your heat exchanger design project. It is much more complicated as compared to this. You need to go through very long iteration process, and many times you need to go through more than one time. Okay, but it's interesting. I tell you, it's interesting. According to the feedback I received from your seniors, at the end of the project, many of them they mentioned it's a very interesting learning process. Okay, so I hope you will also enjoy that. Okay, so what else? So I mentioned already, analysis of heat exchanger, there are two methods, LMTD and NTU. Okay, so I want you to go through these two methods. And in order to use LMTD method, you must know how to sketch the temperature profile. Okay, temperature profile, especially important. How to say? Because in order to use this is actually especially important for 1-1 type and 1-1 type and also double pipe heat exchanger. You must draw the temperature profile. Okay, if you don't draw it, and the direction of the flow is very important. It's either parallel. Okay, in this case, it's parallel, or most of the time it is opposite of parallel is what? Start with C. I can't remember the term.
Perpendicular.
No, not perpendicular. If the flow is perpendicular, it's called cross flow. Okay. If perpendicular 90 degree between the two flow, this is called cross flow heat exchanger. Okay, and this parallel. Just now someone typed is called what is that? Counter flow. Yes, thank you. Counter flow. Okay, counter flow, it means if parallel flow is like this, right? But if counter flow is like this. So hot stream like this cold stream, right? Both parallel. Then if counter flows, hot stream, cold stream, or opposite, hot, cold, Then if cross flow is, let's say it's hot is here, cold is here, or it can be opposite as well. Hot, cold, no problem. Okay, here also hot, cold, no problem. Okay, so these are the three types of flow. Cross flow, 90 degree between the flow. Parallel means in line. Then counter flow, opposite direction. Okay, most commonly used is this. Okay, because better. The professor will explain why counter flow is the most commonly used type of heat exchanger. Okay, this is very, very unusual parallel flow. Okay, in the video lecture you will know why he will mention. Okay, what else? Okay, he also mentioned for heat exchanger the temperature difference you need to use is the log mean temperature, right? Log mean temperature difference, not the average temperature difference, not this one, right? Not you plus inlet to outlet then divided by 2, no. Okay, not the TB average. Okay, this is only for pipe. You cannot use it for heat exchanger. For heat exchanger, no choice. You must use LMT T log mean, delta T log mean. You must use for heat exchanger. Must. Remember, but the difference is for heat exchanger depends on type. Just now I mentioned already. If one type or double pipe, okay, then you don't need to do delta Tm equals to delta T log mean, meaning Ft, the correction factor, equals to 1. You don't need to do correction basically. But for multiple passes heat exchanger, for example, 2, 1, 2, right, 2, 4, 2, 8, multiple passes, then delta Tm equals to delta T log mean times correction factor. How to determine correction factor? Using graph. Okay. Yeah, so here you will see in the video lecture, the professor teach you how to get the correction factor using graph. But I want to tell you, the graph he referred to is different from the graph available in our textbook. This is the graph available in the textbook. Okay, this is the graph we use. Okay, so it's different, okay, it's different. So you see different type of heat exchanger. This is for 1, 2 heat exchanger or any multiple of 2, right? This for multiple of 4. So you must use the right graph, correct graph. This is for cross flow heat exchanger. Still remember what is cross flow? Cross flow means the flow is 90 degree to one another, right? And what else? So don't get confused. The graph shown by the professor is different because he is using, he used different textbook. Okay, our textbook, the graph is like this. Okay, so I hope that you don't get confused. Okay, what else? Yeah, another one is NTU method. Okay, for this lecture, you start from minute of 12 minutes 41 seconds. Okay, you can skip the 0 to 12:41 because he went through an example. That example is not related to our syllabus. If you want to go through also okay. Okay, but if you want to save your time, you can start from 12 minutes. Okay, for the NTU method video lecture. Okay, so that's all for the overview. Okay, that is what I want to tell you about the overview. I want you to go through these video lectures. Okay, wait, let me show you the e-learning. Can you see my e-learning? Can you
Yes,
see the
doctor.
e-learning?
Yes,
Okay.
doctor.
So for section 1 e-learning, this is video lecture part 4, heat exchanger part 4. Okay, this is about LMTD method. Part 5 start from 12 and a half minutes until the end. So this is part 5 regarding NTU method, right? Then and part 6 also remaining part of NTU method. Yeah, this one, NTU method is an example. Okay, so this is what we want you to go through over this weekend. Okay, then next Sunday, I think we can go through some example. Okay, any question on this?
Doctor, next Sunday macam Wisate.
How so many holidays. Aduh. You guys seem very happy. It's okay. Maybe you just use that time to go through all this video lecture lah. Okay, that's what we have planned for you. What else? Okay, now I want to answer the wait Okay, I want to answer the question some of you guys posted in the Padlet. Can you see the Padlet?
Yes, doctor.
Okay, so here the first question, this person asked, can you explain more on delta T M and delta T log mean? Under what condition? This question is regarding, okay, let me explain to you lah. To make it very simple, I cannot say it's 100% correct or accurate, but I think most of the time this is the rule of thumb we can follow lah. Okay, for heat exchanger, no choice, you must use delta T log mean. Okay, heat exchanger, use delta T log mean because that is a more accurate representation of temperature profile in a heat exchanger. So heat exchanger, delta T log mean. That's all. Okay, but let's say for convection, normally lah, what we tell student for convection, actually I just read something different this morning actually in another textbook. Should I tell you? Because I don't want to confuse you. Okay, you just follow this lah, Just follow this. For laminar flow, you use delta T mean, meaning this one, TW minus TB average, right? But for turbulent flow, okay, you use delta T log mean. Okay, delta T log mean, meaning T equals to the delta T here equals to TW minus delta T log mean. Okay, meaning for turbulent flow, you need to use delta T log mean. As simple as that. For laminar flow, you use delta T mean. Okay. Then next question, temperature profile. I'm not sure what do you mean by the temperature profile, but I guess it's something like the temperature profile I showed just now, right? If you are the one who asked the question. So temperature profile, let me show you what is temperature profile. For heat exchanger, let me see if the temperature profile is here. Okay, this one. This is temperature profile. This is temperature profile. Okay, you see, this is the length, X is the length, right? You see the heat exchanger, this is the heat exchanger, right? Okay, this is the heat exchanger. So, and this temperature, right? So here is the TH in, this TH out, okay, and this TC in, TC out, and this is parallel flow, right? So this is what we call temperature profile. Okay, just to give you an idea what is temperature profile for heat exchanger. Okay, go back to the question. This person asked, can you see what I'm sharing now? Palette.
Yes, doctor.
Okay, this person asked how to construct temperature profile for fouling and non-fouling heat exchanger. Basically, fouling is not considered, right, when constructing the temperature profile. Only TC in, TC out, TH in, and TH out, okay, and direction of the flow is considered. For temperature profile, what you need is TC in, TC out, TH in, TH out, and the direction of the flow, parallel or counter. Only these 6 information are needed. Okay, you don't need the fouling because fouling is needed when you want to determine the overall heat transfer coefficient, U, right? Sometimes to save your time, U is given to you. So if you see the question, let's say like final exam, you see the question, U is given to you, you can say, for Muslim is Alhamdulillah, for other you can say, oh thank God, because it saves so much of your time. You don't need to determine the U by yourself. But let's say, unfortunately, U is not given, but instead HI, HO, K value of the tube material is given to you, then you need to use the formula to determine, and fouling factor is given to you, then you need to use the formula to determine the U value yourself. That is a longer process lah. Okay? So pray hard for this final exam. Okay, then what else? The rest of the information I explained already just now, right? For one heat exchanger, you don't need to do the correction because FT equals to 1, right? Correction factor equals to 1. But for multiple passes heat exchanger, you need to determine the FT, the correction factor, using the graph. How to determine the correction factor? Okay, go and refer to the video lecture. Okay, last question: what fluid? Which fluid for tube and which fluid for shell? How to determine the hot fluid is enter tube or shell? Actually, this one, if you when you do your heat exchanger design project, actually you need to determine which one to put in shell, which one to put in tube. Okay, there are many factors determine which one should be put in the shell, which one should be put in the tube. Many factors. Okay, but for the test, right? For if the information is not given to you, then you can just assume because it is not going to affect your calculation result. Okay, but when you design heat exchanger after this, then it's going to affect because you need to determine U. Okay, if U is given to you already, basically you don't need to worry. Hot fluid is in the tube or is in the shell. Don't worry. Okay, because it's not going to affect your calculation result. Okay, so that's all the question. Okay, the remaining time, we are here to answer the question you have regarding the heat exchanger design project. Section 2, you haven't received the heat exchanger design project instruction, right? So Dr. Era will share with you after this. Okay, section 1, you have received that. So now I'm open for question. Very long instruction. Okay, so some important dates, you see, you need to submit a proposal by 18th of May. Okay, 1 week from now, you need to submit a proposal. What kind of heat exchanger you want to design? Okay, go through this. Then on 1st of June, you need to present the interim report. Right? You need to design. You need to present the calculation. Right? Then after that, final, you need to submit technical drawing as well using AutoCAD, 3D model. Okay, you learn already in first year. Don't tell me you don't know how to do that. Okay, what else? Okay, another thing is this database. Because we do this, you see, we assign each group, right, to in charge of different thing. Because you are provided with three very useful references, especially this one, reference one, Chemical Engineering Volume 6, right? So in order to know how to go through the whole process, right, you must go through this Chemical Engineering Volume 6, okay? Because it explained from step 1 until the last step how to do the calculation. And all the graph are inside. Okay, so but it's quite long. So we assign the task to different group so that each group can go through different section in the Chemical Engineering Volume 6, and you summarize, okay, all this information into this shared database. Okay, so that the other group can also refer. You don't need to go through the whole Volume 6 by yourself. Okay, so this is the purpose lah. We want to save your time. Okay, and remember, when you go through Chemical Engineering Volume 6, you must go through example 12.3. There is an example inside Chemical Engineering Volume 6 showing how to do heat exchanger design, step by step. Go through that example so that you have a clearer picture, idea. Then you can also refer to these two videos, right? These two videos also give you some idea on how to do heat exchanger design. Okay, for your information, for this course, right, the soft skill we want to cultivate among you is lifelong learning. Okay, lifelong learning. So meaning you'll be given all this information which require you to do self-studies. Okay, we won't explain this in the class. Okay, because as an engineer, lifelong learning is a very important skill that we must have. Okay, we must know how to look for information and go through all this information and summarize it and get the useful information. Actually, this is called reading skill. Okay, reading skill. Reading skill is a very important skill for the future engineers because there are many information available outside. Okay, so many information. So if you have good reading skill, then you know how to extract useful information from the many information available outside. Okay, so through this project, we want to cultivate lifelong learning. We also want to train you in terms of reading skill. Okay, actually, we kind of save quite provided all this information. We tell you which page to which page, right? But in order to really test you, if you have good reading skill, we only give you this, okay, the whole book, Chemical Engineering Volume 6, you go through yourself, extract the useful information from there. But we want to save your time. So that's why we give you a scope lah. Okay, so we hope that along the way when you go through this, right, you learn how to extract useful information, and you cultivate lifelong learning. Okay, so this is what we want to do. Okay, question. Any question you have? I don't want to explain point by point. I want you to read yourself. If you have anything you don't understand, then you can ask. And take note, these are the topic you are not allowed to propose. Take note on this, ethyl benzene, milk, ethanol, palm oil, engine oil, methanol, blah, blah. All these are not allowed to be chosen because all these topics have been done by your seniors already. Okay?
Doctor,
Yes.
about the title. So among ourselves, we also need to prevent the crushing of title among ourselves.
Yeah. Unless you can prove to me, let's say you choose, for example, let's say you choose, give you one example. Example of a fluid. Cannot think of any fluid.
Cooking oil, olive oil or something.
Yeah, okay, let's say okay, olive oil okay. Okay, you choose, this is the fluid you want to put down, right? So the fluid, two groups can choose the same, provided the cooling fluid you use is different. Let's say one group use water, okay? Another group use glycerol, let's say. If this is the case, then okay, or the process is different. Okay, one is cooling, another one is heating, right? For example, because it's not given to you, right? The heating or cooling, right? Heat or cool, it is up to you. Because we want a real industrial process, you must go and get the PFD, the process flow diagram of the process, right? So you can choose the same fluid, but the process is different. Maybe one is heating, one is cooling, or the fluid you use to cool down or to heat up is different, then it's also okay. Because when all this change, then your calculation is totally different. Then okay, then this is acceptable. Okay, you got the idea?
Yeah.
But most importantly, it's not short sendiri. We don't want you to create a scenario yourself. No, we want you to go and search a real industrial process. A real industrial process with PFD. You know what is PFD? Process flow diagram. Okay, process flow diagram with process flow diagram, and we want you to show which part of your heat exchanger is in which part of the process flow diagram. I think you did it already, right? During your first year. Those attended my section for the 3D model project. You did that, right? So you got the idea already. Okay, most importantly, we want real process, real industrial process. Okay, any other question?
Doctor, second question.
Mm-hmm.
So about the overall heat transfer coefficient U, right? So I remember last time Doctor did say we just follow the equation inside the video, but how about if in the final exam, so we will use the the equation that we are in our syllabus, right? And then the equation, all the information will be provided, right?
Yep. Information. If you were asked to determine the U, right, then you can rest assured that all required information will be provided. All the required information will be given to you because we want to test your understanding. You know how to use this principle to determine the U value. So don't worry.
Okay, Doctor.
Any other question?
Doctor, in
Yep.
the instruction, Doctor did say that there is a sample or what? I, I think is refer to the example lah.
What example?
Oh, um,
Which point?
I refer to the sample report provided.
Okay. Sample report. We will not give that to you first. Okay, because we don't want to give you too much information. Let me see. This one for proposal. Okay, we will go step by step. Okay, so we want you to submit the proposal first because we will check the proposal and tell you if you can proceed. Okay, so we will make sure the project is the heat exchanger you want to design is workable. Then only we will tell you to proceed. Okay, so you don't need to worry about this interim part first. We will provide with more example after this. Okay, so what you need to do now is to I will provide this, the first one for the chapter 1, because we want you to follow the format. Okay, it's a disaster if we don't provide example, then students just do according to their understanding. Then we receive different types, different pattern. Some are very, very long. It's very time consuming. So we will give you example so that you know what to do, what to include in the proposal. So for this part, will be given to you. Okay, this part will be given to you. But for the interim, the sample report will be given after this. After you submit your proposal, after we say yes, you can proceed. Then after this, we will give you the sample report so that you can follow their format.
Another thing is because we need to search the real industrial process. I mean the PFD. So if the PFD is very large, so we just need to cut out the part that we want to include the heat exchanger.
Yeah, in your proposal, you need to show the whole PFD, but you highlight the heat exchanger you want to design. You understand?
Yes.
You paste the whole PFD, okay, but you highlight that heat exchanger, or you can say this is the heat exchanger we want to design. That's all.
Just circle it out.
Because we want to see what process you choose. So if you just cut that part out, we cannot see, right? What is the process? But we want to know the whole process. Then we want to see which part of the process that heat exchanger which you wish to design is in which part of the process.
Okay, understand.
Okay. Any other question? No, okay, if no more question, then yeah. So what we will do, okay, I summarize. So this weekend, and of course coming Sunday, go through the remaining video lectures on heat exchanger. Okay, then we will also give you the instructions on heat exchanger design project, and I will also give you the sample for your proposal preparation. Remember, the deadline for proposal submission is next Wednesday, 18th of May. Okay, so go through the instruction carefully. Then, yeah, if you have question, let us know. But I think the instruction is clear enough, lah. Okay, so that's all for today. Yeah, next week, I'm not sure. We might start meeting face to face. Maybe. Okay. We will let you know after this. Okay. So yeah, that's all. Wish you a good day.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Okay.
Dr. Lai.
Welcome.
Thanks, Lai.
Welcome.